In example 3, we have a nice little situation with an airplane, something kind of near and dear to my heart. Being a pilot myself, we really had to understand what the wind did to you, and the wind did a number of things. Not only could it be turbulence, but as far as your flying distance and time in the air and time to destination. Also the fact that it will push you off course if you don't correct for that. Those things are very, very important. So let's read this here together. A plane is heading due north at 240 knots with a direct crosswind from the west at 100 knots. If the plane does not correct its heading, what direction will the airplane fly, and at what speed? And this is all gonna be in knots. Now, just as before, we can do this geometrically, and to do that, we need to make a nice starting point. And because we're just going north and west, what I'm going to do is I'm just going to kind of pencil in a few lines here, and we'll see where that gets us. And I think we'll need to move this up just a touch. There we go. And what we will do here is we're going to use this as the starting point right here. So I'll darken that in. Maybe you can see it a little better at home. And what we're going to do is we're going to draw these vectors. Now, we have to decide on a scale, though. So, for a scale, even though this is in knots, we could equate a certain distance, which is a magnitude in vectors, as being equivalent to a certain amount of knots. I think probably if we did maybe, I don't know, 1 centimeter equals 50 knots, that would work, and the abbreviation there is KTS if you want to do the knots abbreviation. And so we'll draw this first one here. It says the airplane is heading due north at 240. So if we do 240 divided by 50, we come up with about 4.8. And so the length of this needs to be proportional to actually what it is trying to measure. Kind of a neat thing with vectors. So this vector here, this is going to be the airplane, and this is not the distance that's flown, this is not what it looks like, you know. This is the speed of the airplane, and we're equating 1 centimeter to mean 50 knots. We could do the same thing with the wind, so the wind should be at 100 knots due west, so that'll be from the west traveling towards the east. And this one will be 2 centimeters if our equivalency works out here. So there is this one. That one's at a little more than 2. So maybe we should have stopped right there. Squeeze that in. And now we can geometrically put these two together. What we could do is we could draw this first one, and we're going to draw it at 2 centimeters. A little tough to do here with the Sharpie, but should work. Alright, so 2 centimeters is right there. And then we can do the other one as well. So we could do, and we'll do, this is the wind of course here. And we'll do actually the plane now. So the plane, that should be right there. And the actual path across the ground will be this one. And I'll do that in black. So, using the parallelogram method, this is the actual path of the airplane on the ground. So that kind of makes sense a little bit. I mean, if you had an airplane, and we'll just use this, this eraser head here, and the airplane was trying to fly north, or headed north, but the wind was pushing it from the west to the east, it would seem like the airplane would travel a little bit more west than it normally would without any wind. Without any wind, it would just travel straight north. We can actually measure this thing, kind of the cool part of this, and figure out what the heading of the thing will be, or at least I should say the track over the ground. The plane's heading north. The track over the ground, though, is not going to be north. And it looks like I need to extend this just a touch, so if you need to do that, feel free. And then we can put this right on the guidelines. And I think this thing is reading now right at about 66. So that would be this angular difference here would be actually 90 minus 66, or 24. So the airplane is going to be blown 24 degrees off. That would be this angle here. Remember, we were going from a heading of west up to here to measure our 66. So 24 degrees from due north is where the airplane would actually track. And we could also, believe it or not, measure the speed using this method. And if we try that out, all we need to do is measure the magnitude. So the magnitude of this thing looks like it's about 5.5. So at 5.5 centimeters, we could then type 5.5 times 50 and get the speed to be 275. So the plane will be traveling 24 degrees off course at 275 knots, a little more than it actually traveled on its own. So you can imagine the wind is helping you a little bit in that direction.